All right, let's go ahead and get started. My name is Randy Hoyt. This talk will be on integrating with third-party APIs. I'm a web developer and teacher at Treehouse. Treehouse is an online education company. We have video tutorials on web design, web development, and business and entrepreneurship, things like HTML, CSS, JavaScript, PHP, Ruby on Rails. This whole stage is part of the Treehouse Skills stage, so all day today we'll be having talks by different Treehouse teachers. If you want to learn more about us and learn some of the skills we teach, it's at teamtreehouse.com is our website. In today's talk, we're going to talk about APIs. We're going to talk about what an API is, a lot of different layers. It's kind of a scary sounding acronym for people who aren't familiar with working with APIs, so hopefully we can demystify some of that. And then we'll walk through 3 examples of integrating with web-based APIs. We'll talk about a number of different techniques for getting data and posting data out to third-party services. A lot of web services these days, like Facebook, Twitter, LinkedIn, Amazon, have APIs that allow you to pull data or push data out to their services. And a lot of really great web applications are built using these APIs, mashing these together, or using that data in meaningful and interesting ways. So we'll be looking at a few different examples, and we'll be talking about best practices. Not a big fan of the word best practices, just things that are a really good idea to do, things to think about. So tips and tricks would be another way to kind of summarize that. So let's start by talking about what an API is. This is an initialism or an abbreviation for the term Application Programming Interface, which probably sounds even more scarier than just API. So we'll start by breaking it down by talking about what an interface is. An interface in general is a point where 2 systems, subjects, organizations, etc. can meet and interact. A really good example of an interface is a keyboard for your computer. So if you want to tell the computer what to do, you don't have to get out an electromagnet and try to move electrons around. Instead, you have this really nice interface where you can press a key, like the letter A. The keyboard will turn that into some kind of digital representation. It'll send the computer, hey, they pressed key number 65, and then the keyboard or the computer will handle what to do with that interaction. So the keyboard is a way for you to interact with the computer through an interface without actually having to get down and move electrons around. Another example of an interface is a remote control for a TV. So it's, again, you press some keys and the TV will do things. You don't even have to be by the TV, you can be far away. And even looking at a lower level, like the infrared on the TV is an interface. So the TV has an infrared receiver that is an interface. So the remote control can talk to the TV through the infrared interface. Interfaces don't even have to be digital. If you think of like a key and a lock, this is an interface. So if you want to unlock the door, you have a key that allows you to interface with the lock. You don't have to get out a screwdriver and try to, jimmy rig the lock. There's a nice, easy interface you can use for unlocking the door. Now, when someone makes an interface, like a lock, they'll give you the key with instructions for how you can utilize that interface. Usually those instructions will come from whoever made the interface so that then you can interact with it in whatever ways you want. So like if you think about the keyboard, if you wanted to make a mouse, the computer itself will have an interface and some instructions for how you as a mouse manufacturer would make your mouse. You just follow the commands that they give you in your interface, and then it will allow people to interact with it. Now stepping a little deeper into an application programming interface, this is an interface that allows 2 software components to communicate with each other. A few examples of this, think about if you had your Android phone and you were developing an app and you wanted to launch the camera and take a picture. So the Android SDK has a camera API. It has commands that you can write in your app that will access the camera. You don't have to write code to take a picture or save a file. You just call the commands that they give you, and then it will access the camera. So this is a good example of an API. The code you would need in your app would be something like this. You would include a camera file, and then you could have a camera object in your software that you can call methods on that would then allow you to interact with the camera. You're not having to worry about electrons again or electronic circuits. You're just calling in your software another software component, and it handles the whole integration with the camera. If you're building on top of a platform like WordPress, WordPress has an API known as the plugin API. These are instructions that you have to follow if you want to make a plugin. So you don't have to change WordPress's core code. You just follow their instructions. Their instructions are pretty simple. You put a PHP file in a particular folder with a particular name. You add a little bit of code at the top as a comment, and then WordPress will treat this file like it's a plugin. And then you have access to a number of different functions in their API that you can call. So again, it's nothing fancy. It's just a set of instructions you have to follow if you want your software to interact with another piece of software. The third kind of example of an API I want to mention is in HTML5, there's a new element called the canvas tag. It also comes with what's known as a canvas API. It allows you to draw pictures, draw pixels on a canvas with JavaScript. So you have one piece of software, your HTML file. You have another piece of software, which is a JavaScript file. And through the canvas API, you can actually interact with them. So your JavaScript would look something like this. You would call a command. You would get the canvas element from the HTML file into a JavaScript variable, and then you could call methods on it. So you could call a fill rectangle, draw image. You're not actually changing any HTML code. You're writing JavaScript software, but that through this API will interact with the HTML code and draw pictures on the HTML canvas. So these are all a few different examples of APIs. It's not anything magical. It's just predefined ways for two pieces of software to talk to each other. Today we're going to be talking about web APIs. So with all of the examples I've used so far, they don't use the internet. The key in the lock doesn't communicate over the internet. The Android app accessing the camera, all that's on the phone. But we're going to be looking at web APIs. These are APIs that the software components are on different pieces of hardware. They're on different servers, different computers, and they use the internet as a way to communicate. You'll often hear the term REST when you're talking about web APIs. This is an abbreviation for the term representational state transfer. If you're using APIs, you don't really need to worry about what all that means. I'll kind of talk a little bit about it as we go. But you'll often hear web APIs referred to as RESTful APIs. Just so you know what that means. It means you can hit a web address, you can get some data back, and you can interact with it over the internet. We'll be looking at three examples. Like I said, the first one is my Treehouse profile. So if you're a Treehouse member, you have a web address for your profile. It's at teamtreehouse.com/your username. And this is a representation of your user. So there's a picture, a name, a list of all the badges that you've earned, all the skills that you've acquired through Treehouse. Now, imagine I wanted to pull this data from the Treehouse website and display it on my personal portfolio page. Maybe I wanted to have a widget in the sidebar that showed off the Treehouse badges that I've earned. Now, I could, every time I earned a badge, I could go edit the HTML on my website, but that would get pretty painful. I could just pull, instead, this data through the API. Treehouse has an API. It's a pretty simple API that lets you pull this data in a format known as JSON. So this is a very popular format for APIs. It's text-based, it's standard, and it's designed for passing data back and forth between, well, it can be passed between any two software components, but it's very popular with internet-enabled APIs. It stands for JavaScript Object Notation, though it doesn't have to be used in JavaScript. Part of its popularity is that it is in a JavaScript format, so if you are pulling in data with JavaScript, it's really easy to parse in JavaScript because it's a native format to JavaScript. Another format that's often used is XML. That was one of the more popular formats for web services at first, but it's a lot of work for JavaScript to parse XML. It's way easier for JavaScript to parse JSON. So a JSON object would look something like this. There's curly quotes and parentheses around it, and just makes it an object. And this would be a JSON object for like a person record, their first and last name, an address, and a phone number. So this is data about the person. And the thing with REST is that you're often thinking in terms of nouns. So you're thinking in terms of what's all the data about this person, or about this to-do item, or about this Facebook update. There are some other ways of integrating that are more verb-based, like SOAP or RPC. But REST really is the dominant form for web-based APIs. And you're always thinking in terms of nouns. So what is all the data about this particular object? So with the Treehouse API, if you just go to teamtreehouse.com/randyhoyt and add .json at the end, instead of seeing the web page with all the information about me, you would see this beautiful piece of JSON. This is beautiful to programmers, probably, maybe not to everyone. But this is the JSON object that represents my user at Treehouse. It has my name, my username, the web address for my profile, the images, and a list of all the badges that I've earned. So this is a publicly accessible web address. If I hit it in my browser, I can get the JSON, though there's not much I can do with it in the browser. Instead, I might want to hit it from my code. So I've created a simple HTML file here. It has the head with a title and a style sheet, a body with a headline, and then there's this empty div with an ID of badges. That's where we're going to put the badge data once we get it. And we're going to use jQuery to make the request to the API. jQuery has a nice JavaScript wrapper around these kinds of requests. What we're going to do is make an AJAX request. You may have heard that term. AJAX, I think it used to stand for asynchronous JavaScript and XML. It's sort of just become its own word that doesn't really stand for anything anymore, primarily because XML is no longer the standard format for AJAX requests. Now it is actually JSON, and AJAX doesn't sound as good. So we still use the term AJAX, even though we're not necessarily talking about XML. But this is a technique used by the browser to retrieve data from another server in the background without interfering with the existing page. So if you ever click on a link and the page changes, pulling data from another server, that's typically an AJAX request. So we're going to write an AJAX request here for this web page that will pull in data from the Treehouse API. With jQuery, it's pretty simple. You just create a method you call the method on the jQuery object AJAX. You pass in the URL that you want to call. You set a type. We're going to set the type for get. This is because we're getting data. We'll talk a little bit more about the different types that are available through REST APIs. But this will then call the URL, and it will get back the data. This next function here is what we do with the data once we get it back. I won't walk through this in too much detail, but we'll retrieve a JavaScript object. That's that JSON object. The JSON is text-based, but jQuery will convert it into an actual JavaScript object we can work with. We'll set up some variables. We'll create one unordered list that will contain the list of badges. Then we loop through this for loop. We loop through all the badges that we get. We create a list item for that badge. We create an image tag for that badge. We set the source equal to the URL we get back from the JSON object. Then we append the image to the list item, and we append the list item to the unordered list. And then we append the unordered list to that empty badges div. So when we refresh the page in the browser, it'll look like this. So it's going to pull all of those badges from the Treehouse website and load them into this web page. Does all that sound good so far? Everybody following that? All right, so let's take a look. I've got some nice little icons here where we can talk about architecture of APIs. So the laptop here is the user's browser. The user types in a web address for our web page. It'll send off a request to the server where the web page is hosted. The server will send back that HTML document we just looked at. That'll have the HTML and the JavaScript code in it. Then the JavaScript code will run in the browser. It'll send off a request to the Treehouse API. You got to have a picture of a cloud if you're talking about APIs here. We'll send off that request. The API will send back a list of all the badges, and then the JavaScript page will load in the browser. Using JavaScript like this, what you'll notice is the web page will load, then it will kick off the AJAX request, and then the badges will come in and load. So there will be a delay using this approach. And it will happen on every page load. So every single time someone visits this web page, it'll send off that AJAX request, get back the data, and there'll be that delay. There are a few other ways that you can architect APIs. This is probably not the best way. It's the simplest one to understand, but like I said, every page request is going to be making these API requests. So instead, another approach that we can use is when the browser sends off the request to the server initially, we can connect from the server to the API directly. We can get, instead of using JavaScript, we can use some server-side code. We can get back the list of badges. And then when we send the data, the HTML file over from the server to the browser, it can already have the badges inside of it. So there won't be that lag between when the headline loads and the badges load. Now, still in this example, every single page request is making the request out to the API. So we'll talk a bit about how we can improve that here in a second. I showed you some JavaScript code for connecting to an API. If you were to connect with a server-side language like PHP, your code would look something like this. The protocol that's often used for this is called curl or CURL. It's a way that a lot of servers use to connect out to third-party websites to get data from a particular URL. So this is what the code would look like. You would create a curl object, set some properties, execute the curl command, get back the response into a PHP variable, and then you would close the curl connection. There's a lot of other properties that you can set, things like timeouts, how long you should wait back for a response, and a lot of other things that you can set up when doing that. If you are going to do it on the server side, I would recommend using some kind of library that handles a lot of those timeout variables, what to do with the responses. For PHP, there's one known as HTTPful. That this is an example. You would include the library, and then you could just make one call and say, I want to make a GET request to this web address and get the variable back, or the value back in a variable. If you're using Ruby, you can use a gem like HTTParty, which will do essentially the same thing. You can just make one function call or one method call to the library, and it will give you back that response into a variable already optimized. It'll parse through the JSON and turn it into a Ruby object that you can interact with. Depending on what platform you're building on, like if you are building on top of WordPress, for example, it has its own library for handling these requests. And it's always a good idea if you're writing a WordPress theme or plugin to use those. They do a lot of optimization for running inside of WordPress. They use these function calls themselves inside their core code, and you can take advantage of that if you're building on top of that library. So just a function call to WP remote get, pass in the web address, and they'll give you back that response already formatted into a PHP variable that you can use. So looking back at the architecture, this is the server-side architecture we looked at a minute ago. Instead of making this request out to the API on every single page request, what we could do instead is we could introduce a database component where we could cache the results. So when the user requests the page, we can go out to the Treehouse API, we can get the badges, and then we can save the badges in a database. And then on subsequent page requests, instead of having to make that connection out to the API every single time, we can just pull the data from the database as we've cached it. Obviously, the data will get out of sync if we do that, so you can create a server-side job that runs independent of any page requests, run on a schedule. Basically, the server will initiate the API request, get the badges, and save them. And then after that, every subsequent request for a web page will pull the data from the cache. I've got a little clock there. It usually runs on a schedule. You'll often hear developers talk about scheduled jobs as cron jobs. On a Linux server, cron is the protocol that's used. That's C-R-O-N. It's the protocol that's used for scheduling tasks. So you'll very often, like with this case, if I were doing this on my personal website, I would probably schedule a cron job to run every hour to pull down the latest badges. And then whenever anybody visited my personal website, it would pull that list of badges from the database. It'd never be over an hour old. It wouldn't be up to the minute real-time data, but it would be never more than an hour old. When you're looking at different ways to architect these API integrations, there's two questions that I always recommend asking. Does the data have to be real-time? In this case, I don't think it does with my Treehouse badges. If it's an hour old, that's not a big deal. I'm not cranking through badges every 5 minutes where I need to have that up to date in real time. Another way I like to ask that is the data worth waiting for? And if someone visits my website and I want to just show them my Treehouse badges, I don't want to make them wait longer so that we can get the real-time data. The data is not really worth waiting for. So caching it and serving it up, as long as it's no more than an hour old, I think we'll be fine. The other main question you want to ask with API integrations is, what if something goes wrong? Once you get two systems talking together, there's likely going to be times where something goes wrong. In the very first example where it was an AJAX request, what if the Treehouse site is down for whatever reason, or there's network traffic? There's no reason for my website to keep loading and loading and loading for 30 seconds only to finally give up and not show any badges. With the way we've got it architected now, like this, if the Treehouse site is down when the cron job runs, then the data just gets a little more out of sync. So it might be 2 hours old if one of those scheduled tasks run long. But the user isn't waiting for the page to load longer. The user isn't going to see an empty widget on the sidebar. They'll still see badges. They'll just be a little outdated. So, and we're going to look at two more examples of integrations, and we'll ask these same questions. I think these are really the questions you want to ask when you're figuring out what's the best way to architect your integration. Does the data have to be real time? Not just would it be nice if the data was real time, but does it really have to be real time? and what do you do if something goes wrong in the integration at that moment. Before we move to the next one, any questions over that? Everybody following so far about how we're integrating these two systems, client side, server side, all this architecture stuff? All right, the second example I want to look at is a website called ShopLocket. This is a website, they say it's the easiest way to sell any product online. So you create a ShopLocket account, you go in and you manage your catalog of products there. And then they give you embed codes that you can use, like you can put in the sidebar of your Blogger blog, you can put on a page on your own website. It's handled through iframes. It's really nice. You can actually check out on your own website through the iframe. You don't have to go to a third-party storefront. It's a really nice way for people to get up and running with a store really quickly. ShopLocket hired me to build them a WordPress plugin. They want a lot of their customers on WordPress, and they wanted an easy way to integrate their customers' WordPress installations with their ShopLocket product catalog. So imagine you're writing a blog post announcing that you've got a new product, and you want to drop that embed code right into the product. You could open up ShopLocket in another window, copy the embed code, and try to get it all working, but instead we've built an integration with through their API. So there's an Add Product button here. You click it, it pops up a modal box still within WordPress. We pull in all the products through the API. Then you can pick a product like this. It'll give you a preview of what the embed would look like. And you click Insert Product. It'll drop the product into your post, and then you can publish your post, and on the website, it'll look like this. So you're able to get all that data from ShopLocket's API without having to leave your own WordPress installation. So we'll walk through this one and talk about its architecture. One big thing that's new here is authentication. So in the first example, my Treehouse profile is public information. Your ShopLocket catalog, though, is not public information. So this is something you want to manage through authentication. There are a number of ways to handle authentication, but I think the most popular and standard for web-based APIs is a service called, or a protocol called OAuth. This is a way that lets one application get an access key or a token to use the data in a third-party API. Example they use on the OAuth website is like a valet key for luxury cars. If you have your luxury car and you go to some fancy restaurant and you want to give it to the valet, a lot of these luxury cars have a valet key that doesn't give the valet full access to the car. A lot of times they can't open the trunk. This key won't let you drive more than 2 miles from the venue, so it's limited access. So OAuth works a lot like that for your API. So you can, depending on the level that the application allows different permissions, you can set up just certain permissions to be allowed. It'll give an access token to that application. Facebook, Twitter use this. Facebook, if you've ever authenticated an app with Facebook, it'll pop up a number of permissions. You can actually disallow certain permissions. You can say, oh, I don't want this app to be able to do X and Y, but they can do Z. You can set all that up through this OAuth protocol. The way the OAuth protocol works, it is a little bit of back and forth to get it set up, but it's very powerful once you get it set up. OAuth will require you to create an app ID and an app secret key. This will usually happen, like on Facebook, you would do this through like dev.facebook.com, or I think it's facebook.com/developers. You will get an app ID and an app secret key, and then you'll put those into your app. Some apps provide a little more automated way to do that. But you get the app ID and the app secret, and you put those into your WordPress site here, and then we have a button in the settings. You click Connect to ShopLocket. It will then take you to the ShopLocket website. If you're not logged in, it will require you to log in. You're probably familiar with this approach through Facebook when you're authenticating with an app. So you log in, and then the ShopLocket site will say, do you want to grant access to your WordPress blog to your product catalog? You click Connect. It'll then go back to the WordPress installation with this. It'll pass it back a code through the URL. So it'll be a get variable that gets passed back. You will take that code, the access code, and then you will make another API request with that code and your app ID and your app secret. That's like a temporary code that'll work, and you've got to turn it into a long-lived token much faster. So you then pass that code back through a server-side request to ShopLocket, and it will give you back a token. So you'll get this access token now, which you can then save in your database. And now this token is what you use whenever you make the API request. So you call a web address, just like we did with the Treehouse example, except you'll also pass in the token, usually as a get variable, in the URL. And then you'll be able to use these API requests. So in the ShopLocket plugin, after we get that token, we redirect you to a page that says you are now connected to your ShopLocket account. Yeah. Yes. Yeah, so the question is, when you go to ShopLocket, did they have that built? So yeah, as part of implementing their API, they had to build that authentication, that OAuth workflow. And that's how you get the key. Exactly. Their site's built on Ruby on Rails, and so if you are building an API and you want to set that up, they use the gem called Doorkeeper. It's I think the popular Ruby on Rails gem for handling OAuth authentication. What's great about OAuth is it is standard, so if you are writing an OAuth workflow to integrate with one person, they'll follow the standard on their side, you follow the standard on your side, and it'll work seamlessly. And then when you want to add another OAuth flow, like with Facebook or Twitter, it's just the same thing. You pretty much just change the URL, you click the button, and they follow the exact same process on their side. So it's a really nice thing to have standardized. You write to the OAuth standard, the API writes the OAuth standard, and then you can integrate more or less seamlessly. It's not always perfect, but there's usually a little bit of tweaking that needs to be done. All right, so now let's ask the same questions about our API, about how we would configure this integration. Does this data have to be real time? And what if something goes wrong? You might think we could set this up in a very similar fashion to where we run a cron job to pull the data and save it in the database. That's what I would have liked to do. But then we can, every web request, we can pull the data. What's interesting about this one is that it's a WordPress plugin, and WordPress sites, you won't have, in a plugin, you won't have access to the server at the same level you do if you're running your own website. So we couldn't easily schedule a cron job. So instead we took a slightly different approach. On the website, and this is only when someone's administering the website. So when an end user visits the website, we're not pulling this data. This is only when we're in the administrative area, so that you can pick the product. They'll send a request off to the website. We'll pull the data that we've cached out of the database and send it over to the browser. And then what we do actually is on the page, we check if that data is over 24 hours old. And if it is, then we kick off another AJAX request from the browser. So the user, they're inside WordPress, they're writing a blog post. They can just keep writing the blog post. They don't even realize that the AJAX request is happening. But we send an AJAX request off to the server saying, hey, the data we have is 24 hours old. Could you go get us a fresh copy? And then the server will send off the request. It'll get the list of products back from the ShopLocket API. It will save it in the database. And then it actually then updates the site again. So like while they're writing the blog post, they can click Add Product. And if the data was over 24 hours old, the API will refresh that box, so the modal window has the new box. You might say, well, this data does need to be real time. And my initial reaction was that every time you went to edit a blog post in WordPress, we would pull that data in so that it was real time. But then as I thought about it more, people aren't continually adding new products. So a lot of times you would set up your product catalog and it would be right, and you wouldn't need to refresh it on every single time they added a blog post. But probably the more common use case is you would go add a product to your ShopLocket catalog and then immediately go over to WordPress. And so in that sense, it did need to be real time, but it wasn't something that would be updating quite a bit. So to handle that, in this box where you launch the product picker, I just added a refresh button. So we're only making the request out automatically once every 24 hours, just to keep it fresh. But if you did just add a product in the last 5 minutes, you can just click that refresh button, and it will automatically trigger it. So after you get the page load, you can click the refresh button. It'll pull it all down and send it back to your browser. That way we're not sending off a page request every single time someone writes a blog post. But if they know they want one, if they know they want an update, they can manually initiate that refresh. So, any questions on that? That's that second example. Yeah. Let's get you a mic. It's getting louder. Can you push the mic back there? Thanks.
Just sort of wondering what the overhead would be on making an update request, i.e. has it updated in the last 24 hours, if so, and checking it that way.
Oh, yeah. There still is quite an overhead to send off that request to get like a last update time, get it back, and then handle that. It would be a lighter load to ask the server, hey, is the data new? But I think in order for it to be useful, you'd have to send that off every single time they were in their WordPress administrative area at all. And so they will be spending a lot of time in there, and almost all the time the request would be, no, it's not updated, no, it's not updated. And so, yeah, exactly. Yeah, exactly. So it really is always situational. You always have to ask, how important is that the data is real time? Is it worth the expense of sending off a page request every minute, every 5 minutes, every hour? And obviously, if you could automate it and the user didn't have to click refresh, then pulling data in every hour, if that would help, you could cut that down. But in this case, almost all the time you would have no new products, and so checking it once every 24 hours seemed like the right approach, just to make sure if something had gone wrong, and then have that manual refresh button. All right, so far we've looked at getting data from these services. The next example I want to look at is about posting data to one of these services. So I run a social media publishing tool that lets you schedule updates to Facebook and Twitter. So you get an interface like this. You can type a tweet and a Facebook post, and then you can click schedule, or you can click set the time. You get a calendar and some sliders where you can pick what time you want this update to go out. And then you can say schedule this, and it'll put it on your calendar, and it'll say this is going to go out at a certain time. This one is not real-time integration because you write the post and you schedule it and then you leave. So we can't have it kicked off through any kind of AJAX request or user interaction. Just to take a look at the architecture. So here, I'm in my browser, I write a post, and I click schedule. What it will do is it'll send off to the server, and the server will save that in the database. Say, here's a post, here's a tweet and a Facebook update, and it needs to go out at this specific time. Then we also have a cron job that runs every 2 minutes to check the database and see if there's anything that needs to be sent. If there is, then we send the data off to Facebook and Twitter to their APIs to be published. Now in this case, we're looking at, does it have to be real time? It actually can't be real time because the idea is to run on a schedule. And so we have to use a server-side cron job that runs even if the user's not logged in, so that they can log in, write the post, exit out. And the what if something goes wrong is a really interesting problem in this case, because let's say you write a post and then it's going out a day later and then something goes wrong. Facebook's down for a brief second, or any kind of number of problems can happen. The tweet can be too long. I don't know if you follow how Twitter counts the length of URLs, that they use their URL shortener. So every link you put in a tweet actually doesn't count for how many characters it's in there. It's how many characters it would be after they shorten it. Well, their shortener is kind of long, so sometimes their shortener actually makes it longer. So the tweet can be under 140 characters, but by the time they wrap it in their lengthener, it will be too long and it'll reject it. So you have to think a lot more in this case about what do you do if something goes wrong. So the way we handle it is on our schedule. We run it every 2 minutes. If the post fails, then we log in the database that it's failed, and we try again in the next 2 minutes. If it fails again, we try again 4 minutes later. And if it fails again, we try 8 minutes later. Just in case there's like 10 minutes of downtime, we want to be sure to try to pick that up a little bit later on. If it fails the fourth time, then we send an email to the person, to the owner of the account, to say, hey, something went wrong with this tweet or this Facebook update, and we have the error message right there so they can see it. I get those emails as well. That way, we can troubleshoot anything if something's gone wrong. It is too bad when someone schedules a tweet and it's too long and our code somehow didn't account for it, and it tries 4 times. We know every time it's going to fail, and then we get the email. But that is, the what if something goes wrong there is a definite case. Even if it was real time, so even if they said, like, I want to post this now, you'd still have to account for what if something goes wrong in the integration there. Do you want to show the user, hey, it didn't post, retry? Or do you want to go ahead and take it and put it in your schedule and then try again automatically later? So that's what we do. If you did say post now, it would try to post it. It would take you back to the calendar, and it would show a little, like a triangle warning icon that will say, hey, something went wrong. We're going to try again in 2 minutes, or we're going to try again in 4 minutes. Most of the data we've been looking at so far is get. request, so it's pulling data. But this is where we start introducing posts, where we're going to try to create data in the API. So this would be creating a Facebook update or creating a tweet. There's actually 4 methods that you can use in a REST request, and they all relate to the 4 main CRUD operations: create, read, update, and delete. So there are 4 methods that a REST request can use: get to read, post to create a new record, put to update an existing record, and delete to remove an existing record. Because REST is very much about the representation of the state, if you want to change the object, so you got a user record, you want to change it, you call a request with the put method. And if you want to remove something, you would call it with the delete. One thing about integrating with Facebook and Twitter is that a lot of third-party APIs will have a library that you can use. Twitter does, Facebook does. What these let you do is, I showed you before a library just for making generic post requests or GET requests. With Twitter, you can basically create a Twitter OAuth object, pass in all the keys, and it's all set up to kind of handle all the authentication. And then this is a generic request, so you can send off a post request. But actually, a lot of the times you can just call a method like post a tweet, and you pass in the message for the tweet. And so they'll handle like what's the URL, what's the method we have to call, what's the authentication status. They'll handle all of that, and you just have to call a method like create tweet or update tweet. And using third-party libraries like that can be a really nice way to abstract some of that. What's the method I have to use? What's the URL I have to hit? And you just call like update user, pass in the new information. Twitter and Facebook have them for PHP, for Ruby, for Python, for a lot of different languages, and most will. And hopefully when you have to integrate with a third-party IDE, they will have a library available. If not, you'll be doing something more like this, where you're saying, I want to send off a request with a method of post, hitting this web address, and with these parameters. All right, well, that was the third example, so I just want to wrap it up by talking a little bit about some best practices, just some tips and tricks. I just mentioned that one, use available libraries already. The first one, though, is read the documentation. What I find with a lot of people who don't have a lot of experience with programming is they imagine that expert programmers have all the function names and everything memorized, which isn't true. It's actually a lot more of just understanding the logic and then Googling what's the function I need to call for this, or what's the library that handles this. With APIs, though, there's absolutely no pretense about memorization. You just cannot memorize what a third-party API's web address structure is going to be. You just have to read the documentation. Even if you're an expert programmer, you just sit down. You'll save yourself a lot of headache by reading through the documentation. Twitter and Facebook and a number of other services have really good API documentation around if you want to interact with a user object, these are the different URLs you can hit. This is what you have to pass in. And always definitely read the return values as well, because just the JSON will come back. It will be a string, and they can format that in any way that they want. That doesn't usually have to be standard. Oftentimes the web addresses and the methods, those are kind of standard REST practices, but the JSON object that you get back can be anything. And you will find a lot of crazy things from API to API. So like a good example is that Facebook, those tokens that they give you back, they always expire after 60 days. So if you want to be able to have something that runs longer than 60 days, you will actually have to ask your users to log in and click the authenticate workflow again. There's nothing you can do about that automatically. And unless you read the documentation, you won't know. That's not a very standard way for OAuth to work. I don't know any other OAuth integration that handles that. The reason they do that, I think, is because a lot more people, especially non-technical people, use the Facebook API to do things, and so you can log in and invalidate a token, but I think Facebook feels like their user base won't do that as much as maybe some other users. Like if you're integrating with LinkedIn, you probably are a little more tech savvy than a typical Facebook user, and so you'll know, oh, this app did something I didn't want. You'll log in and you'll invalidate the token. Whereas on Facebook, you may just change your password because you don't know what else to do. That is another thing about Facebook. If you change your password, all the tokens that you've authenticated will be invalidated. That can be very painful. That's not necessarily standard OAuth. You don't have to do that. But again, I think it's because they feel like their user base is less technically savvy than others. They probably won't change their password unless they feel like they've been compromised. And so if they change their password, Facebook decides that they're going to invalidate all the tokens. That can be very painful as an integrator. When you've got a high-paying customer at a big brand who changes his Facebook password, and then all of a sudden, all the Facebook updates that his company has scheduled for their 100 brands stop going out. Just as an example, something that I've experienced, it can be very painful. And then they have to go through. I mentioned Twitter's issue with the characters. You'd think counting 140 characters would be really easy, but they have a very complicated algorithm. So you want to make sure you understand what their limitations are, how they'll count characters. So we had to implement this custom JavaScript library that counts characters like Twitter does instead of like a normal human being would do to handle that. So always read the documentation. There's no shame. There's no way you could know any of this when you're integrating with a new API. I already talked about using available libraries. What's great about available libraries is if something changes in the API, they'll usually put out a new version of the library. You just drop that in, and all your code that creates tweets will still work, even if the endpoints have changed, even if the exact methods have changed. So if you can, use available libraries. And the last tip that I would give when you're integrating a third-party API is log everything. Because what will happen if you don't is something will go wrong. You'll get a call from a customer, and then you'll turn on logging, and then you'll have to watch it for a little while to kind of see what happens. So every time you send off a request, make a log that, hey, I tried to send off this request. When you get a response back, log the response. Do make sure there's nothing insecure or confidential in the response. Like oftentimes they'll pass back the tokens. You don't want to log the tokens everywhere. You do want to have those tokens encrypted. But log the response you got back. And so then when you do get that customer support call, when something's going wrong, you have a wealth of data that you can look through and see, hey, what happened? Why was this rejected? Did I get a meaningful error message back from Facebook or not? And just log the whole JSON response that you get back. If you try to just log specific elements, sometimes the data you need is in a different element. And then, like I said, you'll just turn on logging when the error happens. You'll have to let it run for a day while you gather the data. If you'd been logging it all along, you'd have it and can start troubleshooting right away. All right, so that's the talk about integrating with third-party APIs. We have a few minutes for questions before we get ready for the next talk. So go ahead, and if you have any questions, you can ask me now, or I'll be around here at the skill stage all day to answer questions later if you have any.
Cool. Well, if you have any questions for Randy, I have a mic I can run over to you. Anybody? Randy answered all your questions. Well, cool. Well, if you come up with anything, Randy will be around probably all day, right? Yeah.
Or you can hit me on Twitter at Randy Hoyt as well if you have any questions there. So
Cool.
Thanks a lot. The next talk will be from Nick, about 15 minutes. So we'll take a 15-minute break before we get started again. Thank you.